right. Okay, so what's the agenda today? Why we are here today? Such a great and lazy Sunday. Instead of sleeping, you guys are make your time for this session. What's our agenda today? Why we are here?
Dockerizing the
Spring Boot Dockerize. Deploying the Spring Boot application the Dockerize.
Okay, so you guys are expecting Dockerizing the Spring Boot application. Dockerizing the Spring Boot application. Yes, we are here for the Dockerizing a Spring Boot application. But one thing is, it's not about only focusing about the Spring Boot application. First, we'll go for the scratch onwards. First of all, what is the Docker and what is the main purpose of the Docker? It's not about the Spring Boot application. Maybe in the future, if you want to work with something called as a Node.js application, let us say you are working with something called as a data analytics tools. You want to work something called as a Databricks, all these kind of things. So how you can able to Dockerize a specific software or entire infrastructure, how you can Dockerize, that's we'll try to work out here. So in the part of that one, we are taking as a sort of example, we just took something called as a Spring Boot application, but that doesn't mean we are going to be more focusing on only on the Spring Boot. In a layman manner, once we work out this segment, you can able to get a exposure, any application, how you can Dockerize. That may be Spring Boot application, that may be plain Java application, that may be .NET application, that may be if you want to make some kind of a MySQL. So these kind of other existing softwares, if you want to Dockerize also, how you can Dockerize, that's we can see that one. So basically, first of all, how you can able to work with Dockerizing. So how we can able to Dockerize any kind of a software. Before that, first you need to understand what is the Docker. First of all, what is the Docker and how you are going to be using this Docker? What is the main purpose of this Docker? Docker. So generally, people will going to be consider Docker is a IaaS, nothing but infrastructure as a service. It will undercome infrastructure as a service. It's a kind of instead of you are taking care about the infrastructure. So if you use this Docker, Docker is going to be taking care about managing your infrastructure. Everything it is going to be taking care. So that is just a definition of your Docker. So Docker stands for Docker. Purpose of the Docker is infrastructure as a service. But first of all, why we need to give this infrastructure as a service? I do have a lot of infrastructure in my system. I do have a lot of capacity to maintain the infrastructure. But why I need to produce this infrastructure as a service? What is the purpose? So such a big billion-dollar companies, we have that capacity to maintain the infrastructure. We have that capacity to run our infrastructure. But why we need to provide this infrastructure as a service? What is the purpose of that one? For that, we'll do a small case study. So let us do one thing. So we'll do take some kind of a small Java application only, nothing but some Spring Boot application only. We'll do some kind of a case study on this. We'll do one thing. Let us say I have a Java application which is running on a Spring Boot. I'm not talking about the development. So already a developer was developed. I do have this Java application. So this Java application was packaged into some kind of a jar file. I'm considering this Java application packaged as a jar file. So you have your Java application. This is packaged as a jar file. So this Java application, to run my Java application, I need some kind of a infrastructure. Infrastructure means my Java application using certain kind of a tools or certain kind of a utilities it is using. First of all, when you are having any kind of application, definitely you need some kind of a database you need. So consider I'm using something called as a MySQL database I'm going to be using. To run my Java application, the data I'm going to be storing in the MySQL. Maybe I'm using some kind of event-driven mechanisms like my event-driven microservices, all those things I'm using. So that's where I have something called as a Kafka segment also I'm having. So I need to run my Kafka application. So Kafka, all those things I need to expecting. So some kind of a Kafka producers, Kafka consumers, so on. So I need. So maybe in the future, I'm integrating some other kind of utilities or something, other kind of tools I'm expecting. So there, those all things also I'm expecting. So in a simple terminology, I have a Java application. Development was already done. I want to run this Java application. To run my Java application demanding two softwares, that is a MySQL and Kafka. So consider I'm a infrastructure guy. So you just shared the Java application to me. I manually set up the MySQL. I manually set up the Kafka. So let us say, okay. So let us say this setup you set up in your machine. Just consider this is your machine in your system 1 or system 2, some kind of a computer. So in your system, in your machine, you just set up to this one. So you're running this application well and good. So consider this is the dev 1 machine. This is a dev 1 machine. So developer 1 is going to be running his Java application in his machine. He need a MySQL, he need a Kafka. So with this Java, with this MySQL and Kafka, he can run this application. He can able to serve the application. So meanwhile, developer 2 came into the picture. Just a case study we're doing. So developer 1, everything set up to his machine and he's running his Java applications and he's having the MySQL and he's the Kafka, all the dependent things, he's whatever the things he's expecting to run his application, he's taking care of everything, he's going to be running, no issue. So consider developer 2 or some user 2 came here and he want to run his application. He want to run the same Java application in his machine, So he asked me, hey Harsha, could you please share the Java application? I want to run in my application, in my system I want to run. So then what I told is, okay, I expected he had some bit amount of knowledge. He can set up his own wise. So just simply what I did is, I just shared my Java application. I told him, boss, this is a Java application. You can take this Java application and you can run your application. So after I share my Java application, from that time onwards, he started showing the hell to me. So he don't know how to run the Java application. He is some kind of just a operational guy. So he don't know how to run the Java application. He's not a techie guy or so on. So now he's asking, I don't know how to set up the MySQL. Please help me. Okay, I set up the MySQL. And I just mentioned this one. So this is a configuration you need to mention. I need to write that one. Okay. Then later some point of time, he came to me. So your application throwing some kind of unable to find the Kafka, What is this Kafka? He asked me. So then I realized, okay, so this idiot don't know Kafka also. Let me set up that thing also. Then I just set up that Kafka as well. I'm just taking an example. So maybe some other software he's expecting. So that Kafka also set up this his machine. So now developer 2 running my application in his machine. If you carefully observe, whatever the softwares I need to run my Java application, the entire software or the entire number of softwares I just set up in my developer 2. Combinedly, this required softwares to run my application, can I consider this is a kind of infrastructure? So to run my application, you need that suitable infrastructure. Infrastructure is nothing but collection of softwares here. Whatever the softwares you need to run your application, maybe for my application, I need some certain of infrastructure. For a .NET application, I need certain number of infrastructure. For Python application, I need certain kind of infrastructure. For my Java application, I need a JIDK or a JRE. To run my application is using the MySQL as a database, then I'm using the MySQL. So it is internally using something called as a Kafka. It is using the Kafka. So to run my Java application successfully, I need this collection of softwares. This collection of softwares we are going to be considering as a infrastructure we are going to be considering. Infrastructure we are going to be considering. So this collection of softwares we are going to be considering infrastructure. So now the same infrastructure, whatever he is expecting to run his in his application. So whatever infrastructure he need to run my application, so he need to set up in his system also. In his system also, he need to set up. So the same infrastructure I set up in a developer 2. So let us say the one person I'm able to set up everything. So the same infrastructure I replicate in a developer 2 machine also. He happily run his application. No issue on this. He can start working. So my team was grown. Let us say in a single shot, I got something called as 30 interns I came. I took in my team 30 interns. Now 30 interns took the laptops, 30 laptops, and he came to me. Harsha, we need a setup. Now tell me how we need to set up this, all 30 interns. We'll do one thing. We'll do some token system. Intern 1, intern 2. Okay, setup done, setup done, setup done. Should we go like that? So what is our target? Need to set up the infrastructure. So they want to run my application. They want to run my application. To run my application, they need certain kind of a infrastructure. So this setup of infrastructure, if you see, whenever your number of systems growing there, so the effort is going to be increasing. The effort is going to be increasing. Every system you need to set up manually. Every system you need to set up manually. So developer 1 machine, Java you set up, MySQL you set up, Kafka you set up. Developer 2 machine, you set up the Java, MySQL, Kafka. Let us say remaining 30 people, for all 30 people also, you set up this Java, MySQL, Kafka, everything, and so you sorted all the issues. Now, this is where actual problem will happen. As the initial days, you set up everything manually, that's okay. But later, your application expecting a more and more infrastructure. Today, I'm using the Kafka. Maybe later, I'm using some kind of a CouchDB, a different kind of things I'm going to be using. Maybe some vault services I'm going to be using to encrypt the data. So that's how my whatever the infrastructure expected by my application, those infrastructure is going to be growing. So it's not about the cost thing, it's all about the effort thing. As a developer, if let us say I introduce something called as a vault, another new service introduced in my application. Now I need to tell to the dev too, and I need to give the heads up to all the 30 interns. I need to give the heads up. If they're facing any issue, I need to take care about setting all those things. That's where actually people was facing a little bit burden maintaining this infrastructure. So to reduce this infrastructure burden, ultimately to reduce this infrastructure setup burden, they given something called as a Docker. So let us say this is the entire thing happening in a local machines. In your system, in your company, so these are all 30 interns, developer 2, developer 1, everyone in the local systems, they have a reachability to you, they come to here. Assume this dev 1 machine is a server 1. Server 1. Dev 2 is a server 2. Consider like a dev 1, dev 2 you are having a server 1, server 2. Now, similarly, what are the 30 interns we are having? So consider we are having the 30 clients maintaining the 30 servers. Every client, they have their individual service, their individual servers. We are having a 30 clients. Let us say we are something called as a some payroll engines we are going to be running. So we are having the 30 clients we are having. Let us say SAP people having the number of clients we are having. Every people will going to be running their application, their 30 servers they are going to be running. Now, for all the people, we are the one service providers. So if we develop any kind of application, if we fix our application in our product, we need to give a heads up to all these 30 clients, and we need to tell them you need to upgrade that one. So that is where a lot of challenge will going to be faced. So even if you introduce any new software, also if you introduce any kind of a new utility, if you introduce any kind of a new tool, if you do any kind of infrastructure migration, or if you do any kind of a infrastructure manipulation, maintaining that infrastructure manually is a little bit harder. So earlier we need to maintain this everything in a manually. Even that's where maybe if you see in 5 years back, you will get a frequent notifications from your bank servers. So we are not serving this time. We are making some kind of upgradation of our application or infrastructure upgradation. This is what doing. If they do some kind of a bug fixing or all those things, they shut down the server and they need to set up the infrastructure and they need to restart the server. Until they are setting these all the servers, they are going to be showing your application downtime. So because of this infrastructure change, because of this infrastructure management, maybe sometimes your application leads to downtime also. Let us say my application running in the MySQL, I introduce a new feature. So let encryption's algorithm I changed. I use something called as a vault service. So vault service is one of our service which will maintain some kind of a secrets engine here. So that is a little bit different. I'm just telling. As of now, I don't have that high secure encryption engine. So we got this vault service. We want to introduce this high secured vault service engine. Now, to integrate this vault service for this all 30 servers, I need to down these 30 servers. I need to set up this vault service and I need to rerun this one. And after that, I need to make sure every server is going to be running properly. If I got any kind of exception, then I need to debug that server. I need to take care about this. I need to reverting that application, and I need to take care about all the challenges. So this kind of infrastructure management is a bit heavy in your software industry. So that is observed by the Docker people. So what this Docker people observed is, boss, as a developer or as a infrastructure manager, you are keeping a lot of effort maintaining the infrastructure for your application purpose. So developer level, you don't have any issue. You are going to be running your application. That's fine. But if you want to run your application on your client systems, or maybe if you want to run your application in some third-party system, whatever the softwares, whatever the infrastructure required for your application, that's you are going to be setting them manually. So that's where we are having some solution called as a Docker came into the picture. So what this Docker is going to be telling is, so only one time you need to create something called as a Docker image you will create. So let us say I want to run my Java application. If I have some kind of a Docker, what we will do is, so we're going to be tell to the Docker, hey Docker, I need something called as a JDK. I need something called as a MySQL. I need something called as a Kafka. Maybe in future, I need something called as a vault service, so on, so whatever we need. So only one time we'll tell to the Docker, there will create something called as a Docker file or Docker image we will tell. So we're going to be create a Docker image with all this necessity infrastructure we're going to be tell. So from now onwards, if any server, that may be server or a machine, they no need to install all these softwares manually. Maybe server 1, server 2, dev 1 or 30 interns or anything. They don't bother about downloading all this. They no need to download the JDK. They no need to download the MySQL. They no need to download the Kafka. They no need to download the Vault. So they no need to worry about the infrastructure. Simply what they will do is they will just need a Docker. They will just need a Docker. So simply they will just take this Docker image. They just need this Docker. They'll just take this Docker image. Whatever the image I created as a application developer, whatever the image I created, they will just take this Docker image. They will going to be run. So this Docker image is going to be taking care about this, getting the JDK, taking the MySQL, taking the Kafka, Vault, and starting the server, making the configuration. Is this application is going to be running independently or everything that is going to be taken care. So now see, if you consider this is the dev 1 mission or maybe server 1. So they no need to set up all these 4 JDK, all those things they no need to set up. They just need to have a Docker in that mission. That's it, not more than that. They just need a one software. They no need to download the JDK. They no need to download the MySQL. They no need to download the Kafka. They no need to download the Vault. They just need a Docker. So this Docker is going to be run that image. That image is going to be taking care about all the JDK, MySQL, everything. Similarly, if it is a Dev 2 machine or a Dev 3 machine, it is a Dev 2 or a server 2. That anything. So this dev 2 also, they don't need to set up. They just need to download the Docker. That's it. So the same Docker image will ship to the server 2. Will ship to the server 2, and this dev 2 is going to be running his entire application in a Docker. So similarly, I have something called as a dev 3 I'm having, or server 3 I'm having, developer 3 machine or server 3 machine. So they just need a Docker. They no need to set up all those things. They just need a Docker. Then simply I will share this image. Hey developer, take this image. So just you require something called as a Docker, and they are going to be running entire application in their machines. So that's where your Docker is going to be playing the major role. If you observe, what actually Docker is going to be offering is whatever the infrastructure you need, that they're going to be offering as a service. You no need to provide. You no need to do any kind of a configuration. They already given that service. Just you need to take this Docker image, then you are going to be running. So your Docker is actually providing your entire infrastructure as a service. That is where your Docker is going to be help you. So that is the purpose of the Docker. The main purpose of the Docker is will actually undercome to the infrastructure as a service, and you no need to bother about the management of your infrastructure. Simply, if you're having a Docker, so this Docker is going to be taking care about downloading that softwares, whatever you need, running that your application, everything it is going to be taken care. And with this Docker, you can achieve something called as a zero downtime also. So you can manage a single image can able to run the multiple instance of your application. Then you can manage your entire application, zero downtime also. So to manage this Docker in different kind of images, we are having something called as a Kubernetes we are having. So Kubernetes, the main purpose is to manage this Docker images. So what Docker will do is Docker will create a multiple containers for a same image. Sometimes the image itself corrupted, so then we don't have any kind of a backup. That's where we'll create something called as a Kubernetes. So their Kubernetes we are having the pods we are having. A single Kubernetes pod can able to maintain the multiple number of Docker images. So if a one Docker image is corrupted, so remaining Docker image is going to be get up and run. So that's where you can achieve the zero downtime. So it is continuously run your application without any kind of a failure. So that's where you are going to use the Kubernetes. But to get a solid understanding of the Kubernetes, so first you need to spend good amount of time on the Docker. So that's where your Docker is going to be actually playing a major role in infrastructure management. So as a infrastructure manager or infrastructure coordinator or infrastructure developer or as a developer, whatever the infrastructure you need for your application, you no need to worry about and you need to bother about this. So your Docker is going to be taking care about this. So that's where you are just simply using this Docker to set up your environment or to set up your infrastructure or to gain your infrastructure as a service. You are using the Docker. That's what. So in Docker, we are having mainly, you are hearing something called as a two terminologies there. We are having a lot of things, but this is not the platform we are going to be discussing because that is everything we are going to be covering in an extension in a Docker course. So there, what you are going to be internally. So majorly, you need to aware of the two things, that is the image and a container. So you are hearing them frequently. These two words you will hear whenever there is a Docker is there. You are going to be hearing the two things. So image and the container. So what do you mean by the image and what do you mean by the container is a image is a skeleton of your infrastructure. Simply, in a simple terminology, an image is a skeleton of your infrastructure. Whatever the utilities you need, whatever the softwares you need, whatever the libraries you need, that you will mention in an image. Now, what Docker will do is Docker is going to be prepare that image by collecting these all libraries, whatever you need, what are the softwares you need. Your Docker is going to be create infrastructure by using this image. So the image is the skeleton of your infrastructure. So this image consisting all the softwares, whatever the thing you are expecting, everything consisting of this image. So once you create the image, so this image you can able to run in a multiple process. You can able to run a single image, you can able to run as a multiple replicas. The running process of your image called as a container, dear. Once you created an image, you can able to run any number of running processors. The running process of your image called as a container. You can run the same image as a container 1, container 2, container 3. So let us say if container 1 is a down, which means image 1 is a down, similarly it will go to the container 2. Container 2 is going to be server. So if a container 2 is a down, container 3 is going to be runner. So that's how the running process of your image is a container. A container is a running process of your image. So these are the two terminologies you frequently hear in name of the Docker. So Docker will actually consisting of a majorly the entire Docker core concept are depending on this one only, image and the container. Image is nothing but a skeleton of your infrastructure. Whatever the infrastructure you need, whatever the things you need, that you need for this image. So similarly, you are having something called as a container. A container is running process of your image. A running process of your image. You can able to run any number of process of this image. So nothing but a replicas. So you can run the same image as a container 1, container 2, container 3. Container 1 is also image going to be running. Container 2 also running, image going to be running. Container 3 also image going to be running. So if any container 1 facing an issue because of some memory, something is facing an issue, The request is going to be delegated to the container 2. Container 2 is going to be serving your application. Maybe it is busy with some traffic. Container 3 is going to be running. That's where you can achieve the zero downtime of your application, and that's how you can able to serve the more elegant manner to the users. That's where your actually image is the skeleton of your infrastructure. The container is the running process of your image. These are the two things you are going to be hearing. So this is all about the introduction about your Docker. Now we will see practically how we can work out this Docker. So you can Dockerize any application here. Converting any application as an image will call as a Dockerizing. Suppose I'm having the Spring Boot application. If I convert my Spring Boot application as a Docker image, that is called as a Dockerizing. Suppose if I'm having the Node application, if I convert my Node application as a Docker image, that is called as a Dockerizing the Node application. You are having the Python application. If you convert your Python application as a Docker image, that is called as a Dockerizing the Python application. You can Dockerize any kind of application. You can Dockerize any kind of a technology which are supported by the Docker people. So there is something called as a Docker registry we are having. If your software available in the Docker registry, so you can able to Dockerize that application. So that's we are going to be doing now as an example, as because we are so-called the great Java developers. So we are going to be working with the Dockerizing the Spring Boot application. So that's what we are going to be working out this one. So in these steps, what we will do is, first we'll develop a simple Spring Boot application, just a hello world application I'm going to be developed. So just a Spring Boot application we will take. Then second step, we will convert or we will create image for this Spring application. Image means Docker image. We'll create a Docker image for this Spring application. And we'll develop a simple Spring Boot application. Then we create a Docker image for this, and we'll try to run this application. Run this application. In running this application, I want to introduce the two concepts: running image independently. Similarly, we can run your image by using Docker Compose also. There is something called as a Docker Compose. With this Docker Compose also, you can run your application. How you can run your application with the Docker Compose also? So that's we will see. So the token of introduction, I want to give that Docker Compose flavor also. That's where going to be see that's one. So this is today's agenda. So we'll take a Spring Boot application. We'll create a Docker image for the Spring Boot application. Nothing but we are going to be Dockerizing the Spring Boot application. Dockerizing the Spring Boot application. Dockerizing the Spring Boot application. Then we are going to be running this application. That's where we are going to be performing our Spring Boot application inside the Docker image. That's we'll see this one. And finally, to run this image, you can run independently your image. So by using some commands, or you can use something called the Docker compose.yml. So with the Docker compose.yml also, you can run this one. Both having the different kind of a context. So when you need to use this image independently, or when you can use the Docker compose, so those both we will see. So this is today's agenda. So now, as an initial step, we'll develop some Spring Boot application. So let me take my Spring Boot application.
In this 3 steps where we will see container.
Here, running your Docker image application.
Okay.
Go a little bit up, sir, if you don't mind.
Sorry.
Screen up, no? Screen.
Okay.
Just to join late, sir. That's what it is.
So you want to scroll up or?
Little bit, yeah, down. Little bit down, sir. Please. Yeah, fine. Sir. Thank you, sir.
Okay. Yeah. A
Harshit,
quick,
I have one doubt. Creating image for application and infrastructure is same.
you will never, sorry, creating application
Image for application and infrastructure is same or different?
will never create image for application here. You will keep your application into an image. Image means
Okay.
infrastructure.
Okay.
A quick check. So 8:30 people, did you guys to check out our GitHub repository? So I uploaded everything into the GitHub. I mean all our Spring Security, all those things. Ravindra, you guys able to check that one?
Yeah, everything is there.
Yeah, okay. Yeah. So now we'll take this Spring Boot, small Spring Boot application we will take. So let us take a Spring Boot application, new Spring Startup project. I will take some name, some name.
Spring Docker.
Okay, time God, you given me some kind of meaningful name. So some people giving Angel Docker, Dad Little Prince Docker, not like that. The same thing happened in my company also. When I start, when I take some kind of a new intents in my project, as I told that. So I just had a session, I asked them. So one of the new project I'm going to be working. So that is the DTD. So data migration to the cloud. So data cloud, that is we are going to be calling. We want to develop some kind of a microservice. I want to take some names from the interns to give some kind of a cherish. So just they told, just I asked, so what is the name? What the name we want to keep? So I got awesome suggestions. My project name is a data cloud, Angel Data Cloud, That Little Princess Data Cloud, Smiling Data Cloud. From that time onwards, I just stopped asking what's the name I need to keep. First I'm deciding, then I'm going to be keeping. So let us keep a something called as Spring Docker demo. I'm going to be keeping, or you need That Little Princess Docker demo. And Little Princess are there?
Former one is good.
Okay. Yeah. So yeah, same thing. I group com.training artifact Spring Docker demo. That's one. And I will take package also same thing. Com.training Spring Docker demo. That's it. Not more than that. And the project name is empty. Already we given. Even I don't know why it is not taking. Let us do one thing. So because of Sunday, my ID is also a bit lazy. STS also behaving a bit lazy. Next, and I need just a Spring Web. I need, that's it, not more than that. So if you need something called a time life, you can just keep the time life up to your choice. So just this web is sufficient. Simple demo application I'm taking. Next, finish. It's downloading my dependencies. Great. So it's downloaded my dependencies. We are done. Let us go to our Spring Docker demo. The project is this one. This is what we generated now. Spring Docker demo. So the infrastructure, everything was done. So simply what I will do is, I will just add one HTML file. That's it, not more than that. So in a resources, in a static folder, if you give something called index.html, Spring Boot is going to be considered that is the default welcome page. It is going to be give that as a welcome page. So I will just take this one, HTML file. Next, index.html. So Spring Boot by default take two files as a welcome files, either index.html or home.html. If you keep a home.html also, it is going to be considered that is a entry file. So if you just start your application, it will serve that application as a entry file. So index.html I'm taking. So that's it. I'll just simply keep some content here. So some header tag I will take. Like this. Spring Boot with the Docker. Wake up, people. Wake up. Okay, so if you want to apply some kind of a style or something, can just apply. I'm just applying some color red. I'm going to be applying. That's it. So what is the default port of Spring Boot application if I are running?
8080.
080.
8080. So you can just run this Spring Boot application. Yeah, so application is started 8080. So just if you see localhost 8080. So this is the application we got. So consider this is the application. I mean, I don't have any fancy templates or anything. Simple index.html. So this is my application. Consider this is my application. So this application I want to run in a Docker. This application I want to run in a Docker. So we'll see currently how you are running. In your STS, you are going to be running, but don't expect in the production servers, you will take this STS, you will run this one. First of all, in a production server, you don't have any kind of a source code. So just you will have something called as a packages. You will going to be package your application, either jar or var, that's where you're going to be running. So first I need to convert this Spring Boot application as a jar file. So by default, if you mention or if you didn't mention, by default, your Spring Boot considering it is as a jar file. So let us do one thing. I will go to this location, wherever my Spring Docker demo is there. First, I will build my application. Nothing but I want to generate a jar file. So in a target folder, I don't have any jar file. So let us build this one. So I'm taking the command prompt here. What is the command here to build a Maven project? This is a Maven project because you have a pom.xml. If you are having the Gradle,
Maven build.
Maven build.
A better
Okay.
MVN clean package.
MVN clean install.
Maven clean package.
So if you don't want to run any test cases, you are confident about the test cases, go for the MVN package. But this is the first time we are going to be running the application when we need to take care about the downloading the dependencies, all those things also. That's the reason I will take a MVN install I will do. If I take a MVN install, it will download the dependencies. It will trigger the test cases. It is going to be make sure your entire project is going running properly. If you're confident about your application is going to be super perfect, you don't have any kind of a compilation issues, then you can directly do the MVN package. My suggestion is go to the MVN install. So we did this MVN install. So the build was success, which means we supposed to get the jar file. You can see it is mentioning. So in our location, so Spring Docker demo in a target folder, it is generated Spring Docker demo.jar. It is generated. So you can go there. In a target folder, you got this Spring Docker demo snapshot.jar. I don't want to give this much lengthy name here. So I want to reduce my name. I will do one thing. In your pom.xml, so while you build, you can take something, final name. You can give some file name and final name that is going to be considered as your jar name. So I will just keep something called as an app. So because giving this lengthy name while running my application, it's a little bit awkward to me because if I want to, let us say I want to run this application, how you can run your application here? This is a jar application. How you will run?
Java.
Java
Hyphen jar.
Okay.
Target file. That jar file name.
Jar file name. What is the jar file name?
Spring Docker demo.
Spring Docker demo. That is snapshot. Everything we need to give. A little bit lengthy. So even the same command, I need to give in a Docker image also to run my Docker image. So how I need to give the instruction because Docker image is skeleton. I need to give the instructions how I need to run my Java application. So this much lengthy name for our jar file, a little bit awkward, right? So just I want to compress. So that's the reason I'm just taking something called as app.jar I want to mention. So that's the reason what I will do is I will just build final name as a app I will give. So from now onwards, what it will do is that your choice. So if you want to make the same for your jar file also you can do, or you want to just make that as an app, you can just make the app. Your choice. I don't have any issue. If you want to keep your that little prints.jar also, that's fine. No issue. I don't have any objection on that. I'm just keeping this app, just a final name app I'm going to be taking. Now see, so let me I just did this one, save it. So now I will do mvn clean install. I just added that final name as app. Now my jar file is going to be built as a app.jar. The same thing only, but the jar name is a app. See, it is created as a app.jar. Now there is a no that much not lengthy thing. So just app.jar it is created. So installing your app.jar. You can go there in your target folder. You can just see you got a app.jar. So this app.jar I want to run in my application. I want to run in my Docker. So this is my application app.jar. So as a quick check, so let us do one thing. I just stopped my application. So as a quick check, I want to run this application manually. So simply open the command prompt, java hyphen
jar.
jar. Now simply app.jar.
Yeah.
So now your application is going to be running. Just I'm checking is everything is packaged properly or not. Yes, it is run. And if I just go there, reload, now I'm able to get my output here. Well and good. Our Spring Boot application is working fine. So let us convert this Spring Boot application as an image. So that the process we'll call as a Dockerizing. Now we need to convert this Spring Boot application as an image, nothing but we need to Dockerize this Spring Boot application. We need to Dockerize this Spring Boot application. So for that, you need a Docker in your system, dear. If you are using something called as a Mac OS or Linux OS, you can use just apt help get install or m.install. They're going to be install the Docker automatically. If you are using the Windows, you need to get something called as a Docker desktop. You need to get Docker desktop. If you are using the Windows, this will actually help you to set up your Docker in your machines. So based upon a platform, suppose if you are using the Linux, you can go to the Linux one. If you are using something called as the Apple, you can use the Mac OS, Apple chip or Intel chip. So currently I'm using something called as a Windows. For a Windows Docker desktop, you need to set up. So once you download this is the just the exe file. It will come in a .exe file. Just you need to double click and you can next, it will install. But remember one thing, to run this Docker, especially in your Windows or even if it your Linux OS also, your BIOS should be enable something called as virtualization, because your Docker internally expects something called as a virtualization. So please make sure that virtualization is enabled. How you can check that virtualization is enabled is, so just open your task manager. This is one of the shortcut I'm telling. So basically at the time of a starting of your system, if you type the F2, you can go to the BIOS. In a BIOS settings, you can see that one. But if I restart my system, I cannot able to share the screen. That's the reason. You can go to the task manager. There you can see something called as a performance. Click the performance. So if you're able to see something called as a virtualization, everyone able to follow my cursor? Everyone able to see here something called the virtualization?
Yes, sir.
Yes.
This should be enabled in your system. If it is enabled, then only Docker is going to be run here. If virtualization is not enabled, your Docker will not going to be run. Why? Because internally Docker will create its own infrastructure. So that is a virtual infrastructure. That is not a physical infrastructure. That's a virtual infrastructure. For that, your Docker will need some kind of a dedicated memory for that. Maybe if you guys remember, there is something called as a, in olden days, maybe your brothers are working, there is something called as a VMwares we will use. So VMwares will need some kind of a dedicated system, so that the VMwares will actually take some kind of a virtualized environment they are going to be run. So similarly here also, Docker is going to be take something called as a virtualized memory. It's internally create its own infrastructure to share, to make sure some kind of a RAM and thing. So that's the reason this virtualization must be enabled. If your virtualization is not enabled at the time of starting of your application, so you go to the system BIOS settings, there's something called the virtualization setting is there. You can able to enable that one. So if you don't have that knowledge, please don't corrupt your system. So by the starting out, if you do some kind of unnecessary changes, that bias is going to be corrupted. So if you don't have that one, please take some kind of a well-known people, like any people working on the DevOps or any people working on the network engineers. So they will do that one. Otherwise, go to the just to see some kind of a documentation of how to which enable, follow those steps. Don't do experiments on this. That is a very dangerous operation. If you do any kind of a bias settings misconfiguration, that will going to be corrupt your entire system. So if it is not enabled, if you have enough confidence, then do that one. Otherwise, don't touch that one. So this must be enabled. Then only you can run your Docker. You can able to install the Docker. Once it is installed, so you can just get that Docker desktop and you can run. So not the Docker desktop. If you are using something called the Linux, get the Docker. If you are using the Mac OS, get that related Docker. It's all about, if it is the Mac OS, DPMG will get. So you get double click on that, it will install. If you are using the Linux, it will give something called the .tar file. Just it's a matter of you need to extract that one. Automatically, Docker is going to be installed. Once the Docker is installed, so in your Windows, if you install the Docker desktop, you can check in a two ways. So first one is open the command prompt. Just type Docker -version. Spelling mistake. Docker -version. It's supposed to give some kind of this kind of stuff. So it is giving some kind of a Docker, all those things. So Docker -version you can give. So now my Docker version is the 20 version. So this the build is enabled. So this is the one way you can check, or you can just open your search bar in your thing. So just you can type the Docker. It will give Docker desktop like this. You can just click this. This is the graphical representation. So Docker graphical representation. So did you remember? You can execute queries through a MySQL in two things. One is you can use the MySQL command prompt, or you can use the MySQL workbench. So MySQL command prompt is the command line utility to communicate with your Docker server, MySQL server. Workbench is the graphical user interface to connect with your MySQL server. Similarly, here also my Docker is going to be running. Either I can perform the operation. So suppose if you are getting if you need that kind of a developer feel, hardcore developer feel, you can use the command line tools. So like a command prompt you can open. You can type the Docker commands you are having. Once it is installed, it is going to be give that to all Docker related thing. You can use this command line. Or you didn't remember that commands. You are not that much a fan for your command line utilities. You can just use something called as Docker desktop. So this is the graphical interface which will communicate with your Docker, which will help you to run your Docker. So either your choice, you can see the images through command line prompt also, or you can use this application also, Docker desktop, which will actually display all your Docker images, running process, everything. You can see this one. So I just I need that kind of a developer kind of a feel. So that's the reason. First, I will use the Docker CLI. Then I will show how you can run, how you can see all these Docker images in your graphical user interface also. Our infrastructure is ready. So this is the thing you need to know. Nothing more than that. So this is the infrastructure you need to run your application, just a Docker.
So
Even Yep.
sorry to interrupt. So basically by default, virtualization is enabled in your system, or first time also you have enabled it. It was disabled and you have enabled it.
Once I purchase the system, that time it is already enabled here. But
Oh,
I purchased one laptop for my sister, but my sister laptop it is not enabled.
okay.
So that's okay.
So
We are not guaranteed.
okay, we are not done. Okay. Thank you.
Yeah. So my Docker is installation was done, and we have this Docker. That your choice. If you want to use this graphical user interface, that's fine. Or if you want to use something called as this command line, that your choice. So now, coming back to our steps, we are done with our Spring Boot application. We are having our Spring Boot application, and we had a Docker also. Now, second step, we need to create a Docker image for this Spring Boot application. Nothing but we are going to be Dockerizing the Spring Boot application. So that the steps we will do. So to create any kind of a Docker image here, so you need to create something called as a Docker file. You need to create Docker file. You need to create that. They don't have any kind of extension or anything. Simply, you need to create a Docker file. You can use any editor. That doesn't matter. If you take some kind of a STS or anything, that doesn't matter. You can take any editor. So in your project root folder, that is the recommendation what I'm telling. So that is a recommendation in your project folder. You can use a Docker file, or if you want to place your own location, you can place, but that's not the good practices. So in your project root folder, create a file name called as a Docker file. That's it, not more than that. D should be capital. So in a root folder, I'm just going to be creating new other. So just I need a file. You can take any editor with that, maybe Visual Studio, or you can take the Eclipse, or you can take the STS, IntelliJ, any editor you can take. So what are the project you open? So just you can take the file. Next, your file name should be just a Docker file. That is the name. That is the name. If you want to change other name also, you can keep, no issue. Instead of a Docker file, you can make a config file. That's you can do, but not recommended. So because while you are going to be using some kind of tools, it's always better to follow some best practices. So maybe because this is the infrastructure wise, if you keep your own specific name, later you need to hand over your application to the DevOps team. So DevOps team will going to be confused. They'll simply tell, hey, I'm unable to find the Docker file. If you tell I'm maintaining Docker file name as my own specific name, it's not look good. That's the reason it's better to maintain conventions, follow the conventions, good thing. So that's the reason, just to keep your Docker file name is the Docker file. That's it, not more than that. D should be capital here. That is a convention I'm telling, not mandatory convention. D should be capital. So Docker file, just that's it. Yeah, so this is the Docker file, you can see. So in this Docker file, you need to tell what are the infrastructure you need. So based upon this Docker file only, your image is going to be created. You need to describe. So like, hey, this is the image I need. So image is nothing but what are the software you need. So now I have a Spring Boot application. To run Spring Boot application, what you need, dear? To run your Spring Boot application, what you need?
Tomcat server.
Java.
Tomcat already available in Spring Boot, right? If you don't have, then you can include the Tomcat. But Spring Boot application has embedded Tomcat, right?
JRE.
Exactly. So if you take a JRE, so I will just take a JDK for additional comfort. In the future, if you want to debug something, so something running application is going to be failuring, some kind of a matrices, I will take a JDK directly. Okay. So this is JDK. So you can, whatever the software you need, let me change the search engine. It is using the Yahoo.
Sir, I have a doubt here. Sir, who basically creates Docker image, sir? Whether it's a developer or the DevOps people?
That's all about the stage. If in your local machine, developer is going to be create. If it is a production, then DevOps team will create. So it's all about where you're going to be running. Let us say our team, the testing servers or some kind of a DIT servers. So developer is going to be taking care. Suppose it's a production server. Production servers will never hand out to the developers because we need some kind of a production supports, all those things. DevOps team is going to be taking care. And that too depends upon the company culture there. I can simply tell. If a company have efficient team for the DevOps team, they're going to be managing. But let us say in my early stages of a career, I work for something called as a Scratch project. At that time, we don't have a DevOps team. As an architect, I only take care about the Docker images, creations, everything. I take care of that one. It's all about the team and the velocity. After I built my team, so at the time of a Scratch project development, I have only 7 members. So I'm taking care of the Docker image creations, everything. Now we expanded the team. Now we are having the 28 people our team. So we are dedicated team for the Docker. I mean, this DevOps team we are having. It's all about company standards. It's all about your feasibility. But believe me, now 80%, if you're maintaining some kind of a fine-grained team management you are having, there's a team called as a SRE team we are having, service reliable engineers. Those people will take care. Generally, those people will take care. Docker image creations, everything. But as a developer, you need to have a bit knowledge on that. Okay. Is that answers your question?
Yeah, sir,
Those
that's
people
fine, sir.
are created the image into Linux machine, right, Ashok?
Those people?
They are creating Docker image for Linux machine only, right?
That's what I'm telling. Docker is platform independent. So once you create an image, you can run this Docker image on Linux environment and a Windows environment, no issue. Because image is going to be running on a Docker. That is not dedicated to the either Linux or Windows. Just you need to ship this image, which are the machine having the Docker, there's going to be running. So let us say our Java application. Once you compile, generate the dot class file, you can run this dot class file on any machine, right? Just you need a JRE. Similarly, you need a Docker image. Once you create the Docker image, so the machine, even in a Windows machine, if you are having the Docker, you'll keep this image, that Docker image is going to be running on that Windows Docker. If you are having the Linux, if the Linux having the Docker, you can take the same image, you can run on that Linux Docker. There is no platform dependency. This is a platform independent. Images are platform independent. Okay. Yeah. So now we created the Docker file. So now I need to create the skeleton for my image. I need to tell to my Docker image, hey, Docker image. So these all are the things you need to collect. My application expecting this thing, my application expecting some kind of a JDK, all those things. For that, what you need to do is, so here, as because I already worked with this Docker, that thing I can just give that commands in a single shot. But you are a developer, how you need to encounter these things is, so suppose you need a JDK. So just you need to go to that Docker JDK image. Just type for Docker JDK image. It will give something called as like this hub.docker.com. So there you can find, they will give some kind of a example composer files they're going to give. Just you need to get that. See. So if you have whatever the image you need, I need something called as a open JDK. So just you can use a Docker pull, but this is just a temporary. In a Docker file you need to keep. So just you can come down. So you need to keep like this. So starting your Java instance in your application, that's how you need to do this one. So I need the JDK 11. So just I'm taking the from JDK open JDK 11. This I'm going to be taking. This is what I need. And after that, they are going to be guiding how you can build your image, how you can run your image. That's they're going to be telling. So just they're giving the beautiful documentation. You don't need to worry on this. So just you can encounter like this. So here I'm not here to by hearting your comments. So I'm here to explain how you can encounter these issues. So you need to just to go to this hub.docker.com, whatever the image. Suppose I need a JDK. So just Docker JDK image. Google for that. It will automatically take care that taking that link, everything it is going to be tell you. So that is what. So I need to set up this one. So first I need to create this Docker file. So I need this one from OpenJDK. So this will going to, we are telling to the Docker, hey Docker, from JDK. Yeah. Any question here? Someone ask. Okay.
If you are using in Java into 17, we need to keep JDK 17 only, or any other version, anything fine.
That's actually you need to set in a Docker. For example, you need a JDK 17. So just to Docker JDK 17 image. Whatever they are going to be guiding, so that you need to go there. So this. So it is 11 they are guiding. So just 17. This one OpenJDK :17 you need to keep. So just you can go to the JDK 11, 17. So OpenJDK 17 you can keep. Then it is going to be pull the JDK 17. Okay. So here instead of a :11, you can keep the :17. Then it is going to pull the Docker OpenJDK 17. It is going to be pull. So this is the first thing you need to keep from OpenJDK 11. Let us say if your application is the Node application, then suppose this application is a Node application. To run your application, you need a Node.js. Like see, my application is a Java application. That's the reason I need a OpenJDK. So if my application is a Node.js application, I need a Node. Then what you need to do?
Search for node image.
Search for Node Docker image. So just you can go there. They will just tell simply from Node you need to keep, but I don't want to give like that. So you need to go there. So just you can search here Docker image. So Docker pull Node. So just you can keep that Docker node from node. Yeah, this one you can just need to keep. So just a node you can keep. So generally what we will do is, so this one you will keep. So you need to just keep a from OpenJDK 11. So if you keep a from node, it is going to be pull that environment. It will pull the OpenJDK 11 environment. If you keep a from node, it will pull the node image. So that's how it is going to be pull that environment. It will actually make sure infrastructure is going to be ready with that environment. So that's what. And now to run my application, I have a OpenJDK, which means I'm having my JDK in my Docker image. Now, what is the step? We need to copy our Spring Boot application into the Docker environment. This is meaning of actually making a Dockerization. So now, what is our application here? What is our application?
Spring Docker demo.
Spring Docker demo, but we just change that name, right?
App
App
dot jar.
that is available. That is available in which folder? Target folder. So Docker file is currently in a root folder. So from the root folder, we need to go to the target folder. From there, we need to copy this and we need to push into the Docker image. So that's where you can just use add. Add will actually copy. So always remember here, left side is everything is your local, nothing but your machine path. Right side is inside the Docker path. Inside the Docker, if you want to create some folder, if you want to keep everything, that is will go onto the inside the folder. So just a space is going to be separated. So left side, I need something called as a target folder. Inside the target folder, I'm having what is our application name? App.jar. This is my local environment, nothing but in my system, in current working directory, for wherever my app.jar is there, that location I'm going to be telling. Space, right side, this is nothing but your Docker. It will copy from your target app.jar and it is going to be pasted inside the Docker. So inside the Docker, if you want to create a folder, you can give that folder, or if you want to change your application name also, you can change. I don't want to do anything. Simply, I need to place as a app.jar in a Docker root folder. I need to copy app.jar from the target folder. I just need to keep in my Docker folder, just to simply app.jar. If you want to give something called as a other name also, you can give that other name, but at the time of a copying, it will rename your app.jar to that name, whatever you're given. Here, whatever the name you will given, that is going to be do that one. So that's it. So this is the second step. So first, for my application, this I need, OpenJDK 11 I need. So that is taken care by the Docker. And I'm going to be copying my app.jar to the Docker. So that's it. And now I need to give the some exposure. If your application is a web application, you need to open one port. You need to give some kind of a dedicated port to your application. Then only that application is going to be run to your application. That application is going to be run on that. Okay. So what I will do is I will just make something called as a expose, taking the 8080. If you want to give us some kind of a 7070, you can give the 7070 also, that your choice. I'm just taking the 8080. I'm opening a port. Because my application is a web application, my request has to be come out from the Docker. One port I'm going to be opening. So this will actually open a communication channel for external communication. Anyone send the request on through this port number. That's where I'm exposing one port number is a 8080. Because my application is running on a 8080. Suppose if your application running on a 7070, you can give this one. Here you can do one thing also. Suppose if your application is running on 8080 also, but if you want to bypass your request through 7070, you can do that one also, no issue. So then 8080 you can keep there, 7070 you can expose there. In a Docker network, you need to map that one. There is some additional configuration is there. In a Docker network, you will configure all the request which is hitting to the 7070, redirect to the 8080. That's you can do. That's kind of a configuration also we can do. Docker is going to be offering that one. But just as of now, it is sufficient. So don't mess up a more thing. Because we are in initial step, you need to get that context. Initially, if you just mess up all those things, it will actually give some kind of a confusion. So 8080 sufficient. Exposing 8080. After that, you need to tell how you are going to be running your application. So that's where entry point you need to define. Entry point you need to define. This entry point is an array here. This entry point is an array. Everything will take the executable parameter. So how you need to give is each and every command which is separated by the space, you need to give in the form of an array element. So let us say how you are running your application, Java application currently.
Run as Java application.
That's in IDE, but a package is done.
Java-jar file name.
Java-jar
File name.
app.jar we are going to be running. Okay. So what each and every space separated command, it is Docker is going to be treated as an array. So now how you need to define this one is take an array. First one is a Java. Second element is a -jar. Third element is the app.jar. So that's how you need to mention. This is the entry point. This is the entry point. So Java-jar, each and every space, if you're having the space means that will become a one element. If you're having the space means that is a one element. So each and every space separated command will convert it as a element of your array. So this you need to give. So Java-jar app.jar. If you give entire thing in a single element, then you cannot able to get that space here. Then command not found exception you will get. So that's the reason if your command having the spaces, so that you need to give as an element. So this is how you need to give. This is your entry point, Java-jar app.jar. So just you need to keep here. That's it. So this is my entry point. So this is what my Docker file is ready. So if I just run this Docker file, my Docker is going to be convert this Docker file as a Docker image. By this Docker image consisting all my app.jar file, it will take care about all the infrastructure creation. It is going to be taken care. So now we'll convert our Spring Boot application, or we'll create our Docker image and we'll keep our application into a Docker image. So this is my Docker file. Based upon this Docker file only, your Docker is going to be construct your Docker image. So this is like let us say, do you know the pom.xml or build.gradle?
Yes, sir.
So what pom.xml will do, it will guide the Maven, right? What is the dependencies it has to download and what is the application name, what it has to be do, all the plugins it will guide. Pom.xml is actually a descriptor for the Maven.xml, how to build the project. Similarly here also, Docker file is the descriptor for your Docker. So whatever the stuff you are going to be configured, whatever the stuff you mentioned in this Docker file, Docker is going to be read this Docker file and it is going to be build image like that, build image like this. So let us build image for our Docker file. So first you need to go to that location here, that your choice, wherever you are want to open the command prompt, you can open the command prompt. It's better to open the command prompt wherever your Docker file is there. So currently my Docker, we are in a Spring Docker demo. So here I am having, this is a Spring Docker demo created. So this is where our Docker file is there. I'm now opening the command prompt here. So now first I need to build the Docker, So to build the Docker, we have a command Docker build. You can just use the Docker build. -f stands for the file here. You need to mention your location of your Docker file. So if you are not running your command in the current location where Docker file is there, you need to give that path name. Let us say C:, like that you need to give. But actually, we open the command prompt in the same location. So just you can give your Docker file name. Docker file, you can just give. After that, -t is nothing but your image named here. Whatever the image name you want to keep, you can just keep that image name. So I will keep something called as Docker demo or Spring demo Docker. I will keep. This is the image name I will keep. Spring Docker demo I will create. So then from where you need to build. So which is nothing but, so you need to pick that the location. So where your application is there, that location. So actually I open the command prompt in the same root folder. Just I will keep the dot I will keep. So this is the current location. So now what it will do is your Docker is going to be build Docker image on basis of this Docker file, and it will create image with the name of the Spring Docker, Spring demo Docker or a Spring Docker demo, your choice. Spring demo Docker in a current working directory. It will load all the projects. It is going to be load. That's what we're going to be doing. So if you want to check, is there any present images or not, you can just Docker images. You can type. So currently I'm having these many Docker images I'm having. So let me clean these images. So I can just remove the Docker RMI. Docker demo I will keep. RMI stands for remove image. Untag Docker demo latest. Okay, which is one content is going to be running. So Docker PS you can take. You're not either running. RM Docker demo. So no container. Okay. So you can just go there. Here images you can type. So these are all the Docker images. You can just remove this one. Okay. So everything was removed. Docker images. Now I don't have any Docker images. Everything is removed. Clean Docker. So now let us build our Docker image. So just for our understanding, I just removed. Even if you don't remove also not fine. But make sure one thing. So don't conflict the same name for the two images. If you keep the same name also, no issue. Name can be duplicated, but Docker actually internally use something called the hash code to predict every Docker image having their own kind of a hash code. So it is going to be used. If you are here having some name also fine, but you will get a confused. So let me build the image. So to build the image, so this is the command docker build -f docker file -t and docker image name dot you can keep. So that's I just keep docker build -f stands for docker file -t my image name. So just enter. So now it will, yeah.
Sorry, sir. -t is a target or
No. -t is the tag here. -t stands for the tag, your image name.
image name?
Yeah. The images will call it tags in a Docker. A Docker scan to run sensors against. Okay. So, so it is finished. These are just warnings here. You don't need to bother. These are all the warnings. So my Docker image run. So it is a build. You can see. So it is actually got the JDK 11. So which is nothing but it internally created its own infrastructure. Image means infrastructure. It set up the open JDK 11 and one first step, second step, 2 by 2. This is the command we added, add target app.jar. So this is done. Now our image is ready. We can just check Docker images. See, this is the name we given, Spring Docker demo. If you want to see physically, you can just go there. See, Docker demo is image also created. That's what I'm telling you. You can use either this graphical interface or you can use something called as a command line. So Spring Docker demo, you can use this one. So this is my image. Every image having an ID. So just you can use this ID. So in the future, if you want to remove all those things, you can use this ID. So now my Spring Docker demo, it is going to be running. So we don't have any issue. So the image was built. So now this image, you can just package as some kind of a tar file or a zip file. You can just share this image. Any system, if you want to run, just that system need that Docker software and this image. That is sufficient, not more than that. Even you can automate this one also. You can upload this image, something called as a Docker trusted registry. Generally in industry, what we will maintain is whatever image we will create. For example, as a developer or a team, first what we will do is we'll build this Docker image. We'll build this Docker image. After build this Docker image, we'll upload all these images into something called as a Docker trusted registry. Docker trusted registry. So there is a two types of DTRs we are having. DTR stands for Docker Trusted Registry. One is a public DTR, second one is a private DTR. Public DTR means it's like open source. Anyone can able to communicate with your DTR. They can able to pull the Docker image. They can able to set up the environment. But private DTR means company specific. Only my company people who have access, those only can able to pull the images. So we are having the two things, DTR. So in this, once we build my images, we're going to be pushed. For example, currently we build something called as a Spring Docker demo. This image we pushed here. How many images you will create? All the images you're going to be pushed into this Docker Trusted Registry. So whatever the infrastructure they need, for example, developer 1, they will going to be pull this Docker image. Developer 2, they are going to be pull into their environment. That may be server or that may be so on so. That's where they're just going to pull the Docker image. So this process you can automate with the Jenkins tier. So Jenkins, once you just push, so deploying on the particular target servers, everything, there you can just use the Jenkins. By using the Jenkins, you can automate this step also. So once you build your image, so that's a building image, everything also, you can automate through the Jenkins. So you can take the code from the GitHub. So once the build was done, you can convert this Docker image through the Jenkins. Jenkins is going to be taking care about converting as an image, and it is going to be pushed to the Docker Trusted Registry. So once you push the Docker Trusted Registry, whoever want to one, that is maybe a dev one or something called as a server one, they are going to be pull the Docker image. Now see, they no need to set up all this environment in their machines. They just pull the Docker image. They just need a Docker in their systems. They will just run this image. They are going to be run their application. Without any kind of infrastructure effort, they can run their application. So now my Docker image done. So we have a Docker image. So now we need to run this Docker image. So to run this Docker image, you can do simply one command here. That is Docker run -p, nothing but a port, because this is a web application. If it is not a web application, you can just simply do the Docker run. That's it. Just you can give the image name, Docker run image name, that will do. But I need some kind of a port number has to be exposed. So whatever the port you configured in a Docker file, that you need to expose here. So that is, I configured 8080 in my local. I need to expose 8080 from the Docker. So as I mentioned, left side is the local, right side is the Docker. So left side port is the local. My application, I want to access through 8080 port number, which is running on a 8080 port number inside the Docker. That's it. After that, we need to give our image name. What is our image name, dear?
Spring Docker demo.
Spring Docker demo. So that's you need to give. So just paste it. So this, if you give, it is going to be run. So currently, if you see localhost 8080, no application is going to be running in my machine because we are not running our application. I stopped everything. I stopped. There is nothing going to be running. Now I will run this Docker image. So then this Docker image is going to be started. That running process is right. The running thread of your Docker image that will call as a container. So every image is going to be stored the container. A container, you can simply tell a container is a partition for your Docker image, which is running thread. The running thread of your Docker image, that is your container. So your Docker image, you can run any number of containers. So if one container is going to be run, second container is going to be up, a third container, fourth container. It's a kind of, not exactly, kind of load balancing you can observe, but not exactly. There are a lot of differences there, but just a glance idea I'm giving, kind of a load balancing. Same application, it is going to be running on 3 instances. That running thread of your image will call as a container. So you can run any number of containers. Minimum recommendation is a 3, max recommendation is a 10. If you go more than 10, unnecessarily your Docker is going to be hacked. You need that kind of a heavy configuration systems also. 3 is sufficient. 3 is sufficient. Okay. So by default, it will run on the 1 container. So you can just see that also. So that's I'm going to be giving Docker run -p 8080 port number internal, nothing but my local. Whoever want to access my application, they can access through the 8080. That is going to be mapped inside the Docker 8080 port number. So Spring Docker demo, this is my image name. So if your image name is something else, you can just give that something else. So I'm running my application.
Sir?
Yes.
Please, if you don't mind, change any port number, sir. We are confusing. Which one is a Tomcat? Which one is a Docker?
You can just see here,
Here,
8080
colon, left side and right.
left side and right side. So for that, you need another network configuration. That's what I told. You need some kind of network configuration. So that's unnecessarily make you confused. So you can just simply, this is the external ports like this. 8080. So you can just simply left side, whatever it is having, this is local. Whatever the configuration, even in your Docker file also, left side everything is the local. See, target app.jar. Right side everything is the Docker. This is everything is a Docker. So this port is the Docker. This port is the local.
Local is nothing but our system, sir.
Yes, our system. You can access your application 8080. If internally your application is running on 7070, so then you can expose that 7070. So that's, we'll see. If a time permits, we'll see that one also. Yeah.
Sir, sorry to interrupt. Sir, you have written Docker build Docker -f Docker file -p Spring Docker demo. What is dot at the last?
Dot is the current working directory here. So where you need to build
So
your image,
we are currently at the root now.
not your local root. So where you need to build in a Docker, Docker is a consider Docker is some kind of a system, it's a laptop or some kind of a server. So where you need to build your Docker. Suppose if you want to build this Docker image inside the Docker in certain location, if you have any kind of a certain location, so there you can give that location. If you give a Docker, it will just take the default one. So currently, wherever all the Docker images is going to be keeping, it will going to be keeping that. So inside the Docker.
So initially we have run our command from our application root directory.
Right.
And this dot is not that not our application root directory.
Not our application root directory.
Okay, sir.
See, this is your Docker here. This is your Docker. Okay. So inside your Docker also, you are having different folders. You are having root folder, you are having build folder, you are having network folder, you are having. So it's a kind of a system, a system. Now Docker build, I'm calling the Docker. Hey Docker, I want to build. If you mention the Docker build, it will build an image. On which basis? This is the file. I described all the steps in this, and I want to give the name as a Docker demo. So until this, your Docker image is going to be built. Once I build my Docker image, so where I need to keep this Docker image in my default Docker. So there I'm keeping in a root folder itself. Inside the Docker root folder, I'm going to be keeping this Docker image. This is not your application root folder, Docker root folder. So once it was built, it is going to keep in a Docker root folder.
Okay, sir, got it.
Yeah. So that's what, and I run my application Docker run -p this one. So this actually running my application. You can see my application is going to be up and running. We don't have any issue. So if you just go there, the same localhost 8080. So now I can able to access my application, but now my application is not running on my machine. It is running inside the Docker. If someone want to access, they no need to set up this OpenJDK 11. Suppose if my application expecting some kind of everything, they no need to keep all those things. They just need a Docker. They will take this image. I will take this image. For example, see, you can just push to the hub. If you just push to the hub, it will going to be pushed to the Docker hub. They can pull, they can run this. So now see, this is running. You can just go to the containers in this container. So one application is going to be running. So this is inside your container. So it is going to be running inside your container. You can just see how it is going to be running. If you got some kind of exceptions, everything you can able to see this one. You can just open this container. As I told you, it is a running thread. So inside your container, I'm now inside a container. If I type the ls, see, are you able to see app.jar?
Yes, sir.
Okay. So now see, these all are the folders there. Bin inside the Docker, you are having the bin folder, boot folder, dev folder, etc folder. See, you build the image. You build the image. Dot means current folder. It will just kept inside the current folder. App.jar, current folder, like this. So you are having the home folder you are having. So it's your Docker is also a kind of system. Basically, it is internally a Linux system. It is going to be having that kind of a folder structure, everything like a Windows having your downloads folder, everything it is having. Similarly, your Docker also internally having the system. It is consisting all these folder. I want to just to keep inside the root folder app.jar. That's why just to keep the dot. So this is where our entire thing. So inside the container, you can see all the infrastructure. So it is having like a MNT folder mounting. You are having something called a sys sbin. Suppose if you see cd bin folder. In a build folder, I'm having a lot of things. So see all the grep things, everything. It internally create a infrastructure. That's the reason we're calling the infrastructure we're going to giving as a service. If you have a Docker, it is going to be create entire infrastructure. You no need to set up again and again all those things. So that's what, and this is the way we can run our application. As I mentioned, we can run our application, run this application running image independently. That means this one. So you can, once you build an image, you can run image independently. So run Docker run, this is the independent run. But here one thing. So let us say I have a one application and I'm going to be building my application. So I trigger this command, Docker build, Docker run. So everything I did. Let us say I'm having the microservice application, 10 microservices I'm having. 10 times I need to build my application, right? And 10 times, 10 images I need to create manually. And 10 times I need to give this command, Docker run -p, the port number, something 8080, something 8070, like a Spring Docker demo, something I need to give. So that images names. So the 10 commands I need to run again and again. It's a little bit burden. So one time, two time means that's okay. But every time I'm giving this command 10 times, if I'm expecting some kind of a restarting of my application, every time I'm giving this command, little bit challenge. And maybe sometimes what will happen is there is some dependency is there. So let us say if you are working with the microservices infrastructure, my microservices communicating with one on each other through a Eureka service, discovery server. First Eureka server need to restart, then remaining services should has to be restart. That's some, there is some dependency is there, service to service dependency. Once the service is up, then I need to start this service. So to automate all these microservices, I mean to automate all this image running time, all those things, you can use something called as a Docker Compose. Instead of you are running manually, that is what I'm telling. So you can run your image independently. So instead of running your image independently, you can use something called as a Docker Compose. So Docker Compose is by default come with the Docker. So you don't need to set up anything. So Docker Compose, but Docker Compose required a YML file. If you need that, if you just to configure this Docker YML file, you are going to be describing how many services you are having, how you need to start. Is any services dependent on any other service? What is the environment you need? So how you can run all those things you can mention inside the Docker. So that's will just the same application we will try to run with the Docker composer we are going to be do. For that, we need to create something called as a Docker compose.yml. So simply I will do one thing. In the same folder itself, I will keep a Docker compose.yml. New file. My file name is the Docker compose.yml I'm going to be creating. Okay. So Docker compose.yml. If you want to go, you can go for the YAML also. YAML is also okay. YML is also okay. That is all about the versioning. Version 3 is the YML. Version 2 is the YAML. Both are fine. So Docker -compose.yml. So this is the YAML file. In this YAML file, you can describe. So boss, these all are the images I'm having. These all are the services I'm having. Just you need to describe here. Someone is asking the question.
Yes, sir. Actually, my application required MySQL as well as Kafka also. So what will be the changes in Docker file?
Your application need all those things, so like a Kafka, all those things that you can configure in this. So that Kafka, all those things you are not building, right? So already that a Kafka MySQL available in the Docker Composer. You can just need to mention that as a service in your Docker Compose. There's a Docker file for your application's sake. That is not for your global configuration. For your application, whatever you convert the Docker image that you need. Whatever the additional things you need, that you can mention in your Docker compose.yml. So that's I will show now.
Okay, sure. Thank you.
So here, Docker compose.yml. So just I'm going to be taking the version. First, you need to mention with us some version, because which version of a Docker composer I'm going to be using. So mine is the 3. That depends up. Now, if you take anything is a 3 only. If you are using the below Docker 15, that is a 2. So Docker 20, I'm using Docker 3. So there, and I need something called as a services. In this services, YML is a case sensitive. It is follow the very strict indentation here. Even if you miss a small space also, it is not going to be considered that as a key. Services. So here you need to give some name for your service. This is not your Docker image. So a name for your service you need to give, because this is identification for your service. So in your services, you can able to configure any number of services. So I need I just want to make something called as service name, like Spring Boot Docker. Just a temporary name I'm going to be giving. That's it. And for this service, you need to configure what is the image. What is the image you need to mention. So for this service, my image name is, what is your image name?
Spring Docker demo.
So can just take this one. Oh. I'm sorry, it's closed by mistake. Oh, it didn't save. Okay. So version, I'm giving some 3. And services. So there you can just mention your Spring Boot application, Spring Docker, or I can just mention something called as a service 1. That your choice. That's a temporary name. Whatever you want to keep, you can keep service 1. So for this service 1, I need to point an image. So the image name I need to mention. So open Docker images. So this is my image name. So that's I'm just going to be keeping here. So this is my image name. Okay. So I just followed that now. So now it is stopped. See, now it is stopped. So we'll go to the image containers. Currently nothing is there. I will remove this
Hello, sir.
container as well. Yep.
Hello.
Yeah, tell me.
If I add one more class in this Spring Boot project, then Jenkins will automate the build the jar all those things.
One more class.
If I add one more class and if I edit the code in Spring Boot project, so Jenkins will automate the code and create the var file and deploy in the Dockerized image.
Yeah, that's what, right? So once if you do any kind of a code changes, generally what you will do the again trigger the MVN install. It will compile all the
Okay.
class files. It will create a new jar file that you can keep in your Jenkins. So once you create a branch, or if you do some kind of a push, or if you make some kind of a build, then Jenkins is going to build all those things automatically. Yeah. So here my image is a Docker image. So here I want to build my application. So where I need to build is context. Context is nothing but current working directory. That is where I need to build. I'm just going to be describing. So what are the command I am given? I'm just going to be giving this one. So now I need to mention Docker file. For this service, what is a Docker file? So if it's the service Docker file. This is the location there. Suppose if your Docker file is in some other location, you need to give that also. Docker file is the location. Okay. Then I need to build nothing but my application needs some kind of a ports. That ports I'm going to be exposing. So I need some indentation. So that is nothing but 8080:8080. That's what I'm just going to be storing. Okay. So someone asked if I'm having some other MySQL or that thing. So what you can do is, So like the service one, you can just create something called as a other service, like a service one. Similarly, let us say I'm having some kind of a MySQL, can come there. That will become a service 2. So image, you can just mention what are the MySQL image unit, that MySQL image you can keep. So now it will build my image and it will going to be pull the MySQL image from directly Docker, some like a service 3, Kafka, that Kafka I need to mention. So Docker file, you don't require any modification. In a Docker file, what you are doing is how to convert your application as a Docker image. But this MySQL, Kafka, these are all things you are not converting. Already those images available in the Docker. So just you need to pull that one. So just you need to service image MySQL, just you need to mention, then it is going to be pull that one.
Okay, thanks, sir.
So one thing over here, suppose we are having a service one, Spring Docker demo. Inside that form, we are already mentioning about Kafka or MySQL. So what's the need to give into as another service to MySQL or Kafka? Because it's already there into the service one.
Service one, I didn't get you. Service one.
In service one, pom.xml, suppose that we have Kafka and MySQL as well.
What you will give in a pom.xml? Either you will keep a MySQL driver, you will give.
Yeah,
not
right.
not a MySQL instance. MySQL software you will not give, right?
Yeah.
That
Not
MySQL database we need here. So if you are having the MySQL Docker image, you no need to install that MySQL.
Oh, okay.
That a database here, Oracle database, MySQL database, that you no need to install.
Okay.
Yeah.
Sir, that
Okay.
image will have only Spring Boot application, or I'm just quite confused between YAML file and this Docker file.
So whatever the Docker file we created, that is application specific. Docker file consists that application, how they need to build that application image and how they need to copy. That's it. Image that this is Spring Boot Docker demo in consisting only Spring Boot Docker image only. Spring Boot application is consisting. What are the application we developed?
Correct.
Now in this Docker compose.yml, we will define the dependencies.
Okay.
My application need a MySQL. My application need a Kafka. Those external dependencies, whatever we need, that will define in a Docker compose.yml.
Okay. So those applications also, other applications like MySQL, Kafka, they also should have images, right? Those images will be referred here.
Maintain in a Docker DTR. They will maintain in a Docker DTR. So they don't, the things you don't need to configure, they're already having in a Docker DTR.
Okay, those images names we will refer it here.
Yes, just refer.
So basically, how much complex, how my code is complex, my project is complex. I should only involve or write OpenJDK in my Docker file, nothing else.
Yes. Suppose if your node application, you should only involve in a node.
So if my application is communicating with some other applications, I am third party or party, everything, my project is very complex. Still, I need only OpenJDK if it is a Java-based application.
Exactly, yes, OpenJDK.
Okay, and other dependencies which the softwares I need to run, the infrastructure which I need to run, I have to write in environment.
Yes.
Okay, now got it.
Okay, so this is the Docker compose.yml, and whatever the other images you need, maybe some kind of a MySQL image, Kafka image, some suppose in your application itself you created another Docker image. So let us say order service, payment service, that a payment service. So everything you are going to be keeping in this service 1, service 2, service 3, and you will make that a network configuration, and you can make that dependency configuration also. Suppose my service 1 started, then only I want to start the service 2. Let us say first MySQL service has to be started, then only I need to start the my application service. That's I need to configure in this Docker compose.yml. So basically, the Docker compose.yml is actually give the entire infrastructure configuration. So that's you need to give here. So that's it. So my Docker compose.yml is there, and Now we need to build that application. So where my Docker compose.yml is there. So just you need to go there. This is the Docker compose.yml. You can just open the command prompt here, or if you open command prompt anywhere also, just you need to give the file name. Simply what you need to do is Docker compose up. By defaultly, it will load Docker compose.yml. Suppose if you rename, you can give a -f, that file name you need to give. Instead of a docker -compose.yml, if you give a docker build.yml, so then you can use the docker -build.yml. -f stands for the file name. So by defaultly, Docker Composer will going to be pick docker compose.yml from the current working directory. Just you need to give the docker compose up. So now it will going to read your docker compose.yml.
Up means what is the meaning, sir? Up running.
It's just run. Yeah.
Okay.
Similarly, if you want to shut down all the services in a single attempt, Docker compose down.
Fantastic.
So now see, it is going to be creating your Spring Docker demo service one. So similarly, how many images are going to be configured? Everything it is going to be configured inside the Docker. Here, actually, I'm giving a glimpse of a Docker here. So we need to spend some good amount of time, and we need to we have a, suppose if you come to the there in a DevOps there we are going to be spending almost 20 days only execution on this Docker step by step. So now see, my application is going to be running. So it is Docker Composer will actually taking care about your Docker image. It is going to be running your application. Now see, go there. You can able to run your application. And if you just close this command prompts also, you don't require it, because inside the Docker it is going to be running. You can just go there. You can just check your Docker Spring Docker demo is going to be running. So container one Docker demo is going to be running. And just to see how it is going to be running, what is the port, everything. So similarly, you can able to run any number of containers. That is all under part of the configuration. So you need to make the configuration, some kind of a network configuration, all those things it is going to be giving. Yeah. So this is all about Dockerizing the Spring Boot application.
So we are running multiple containers under one dock. Is that right?
Under one image. Every image can consisting number of containers. Every image can consisting number of containers. That's what I'm telling. A container is a running thread of your image. So for example, I created a Spring Docker demo. I create, let us say, order service, 4 containers, payment service, 4 containers. If one container is going to be down, same order service, second container is going to be take the request. Third container is going to be take the request. Every image is attached with the number of containers. That's your choice. Minimum, max configurations you can do.
So in a YAML file, we mentioned one image, right?
Yes.
So if we have a MySQL server also run, we want it, then so we will have one more service in the YAML file, right?
Right.
So we will have two, that means
images.
2 images in the one YAML file, right?
One YAML, yes. 2 images in a one YAML file. And once you start this, you can pick up, let us say MySQL you started, one instance is going to be running. If you want to run the same instance of that MySQL, you can run the container 2, container 3.
So when we run this YAML file, I mean, using the, so both the images will start running, right?
Both, yes, all the, not of both images. How many images you are going to be configured, all the images is going to be start running.
So all these images will run in one container or multiple containers?
That's what. Every image have their independent containers. Not a one. In container, you will never run an image. Image will run on a run with that container. It's
Okay.
like this.
With one YAML file, if we have 2 images, when we run that YAML file, we will have one container running 2 images. Is that the right statement?
No.
No.
So you are having the service 1.
Yeah, assume there are 2 services in the YAML file.
Service 2 you are having. Okay. Now you will convert this service 1 as a image 1. You are having a service 2 as a image 2. You configured this image 1, image 2 in a YAML. So now what YAML will do? So this image is going to be run container 1. If you configure the multiple, the same image is going to be run on a container 2 as well. Similarly, image 1, its own container. Image 2,
Image 2, yeah.
again, container 2.
So
Every image will have
1
their
and
own
2,
dedicated
image 1.
containers.
So, so image 1 and 2 will be running on the container 1 only.
They will not run in a container 1. So
Every image will maintain its separate container.
It's respect to containers. Image 1 will going to be
Okay,
run
let's say,
container 1,
that
container
means
2.
image 2, I can, for clarity, I can take container 3, we can refer, right?
You can understand like image is a class and container 1, container 2 is an object. Easy format of Java.
Exactly.
Okay. So in that case, my Spring application will be running in container 1 and MySQL will be running in container 2. Is that right?
Service 1, if it is a Spring application, Service 1, it is a Spring application. Then container 1 of your Spring application is also consisting Spring application. Container 2 also consisting of your Spring application. For this image, so it is like what I can do is container 1. It's like the double index, multi-index. In Java, multi-index we are having, right? In a multi-index,
Yes, sir.
you are having some kind of a index 0, index 1. If you take this index 0, index 1, index 2, so index 0 is going to be storing another array. Like
No,
it is having one.
Running in container 1, container 2, understood, sir. Service 2, that is MySQL, running in container, you are represented as container 1 here. That's where I confused. Is it a container 1 or container 3 or 4? That is service 2 is
container 1 only here. Every container is independent for that service. Everything is a new system.
Okay, that means image 1 and 2 are both are running in container 1.
Both will run on their independent containers. Their independent container 1. Let us simple. Let us say I have a server 1, server 2. Okay.
Okay.
So server 1 I have a application 1. Server 2 also I'm having a application 1. This server 1, server 2 maintained by your cloud infrastructure. Okay. So this cloud infrastructure is your image. This server 1 is a container 1. This server 2 is a container 2. Similarly, I have application 2. This also server 1. They're independent. This also server 2. Application 1, sorry, application 2. Nothing but your service 2. Here also application 2. So this is your image. Cloud info, this is your image. So this is service 1 image. This is service 2 image. So now service 1 have container 1, container 2. They're dedicated. Service 2 had their container 1, container 2. Container 2. So service 1 running its image in container 1, container 2. They're dedicated. Service 2 running their image in their dedicated container or container 2. So every image will create their own set of containers. That is not the continuous one. Container 1, container 2 for image 1. Container 1, container 2. Again, new containers, new servers creating for the image 2. Container
So
1,
for
container
clarity,
2
I
for
can
image
refer
3.
it as this container service 2 is running in container 1, container 2 you are referring, right? For clarity, I can refer it as they are container 3 and container 4.
Container 3, container 4, if you mention here, then what about container 1, container 2 of a service 2? First, it has to start the container 1, container 2. If it is not there, then only it will go to the container 3, container 4.
How many containers are there in a one image?
That's your configuration. Minimum is a 1, maximum is a 10. Simple. I will do. Okay. Let us do one thing. I got one example here. So we visited some kind of a fast food center. So you want to order a veg, I want to order a non-veg. Let us say McD we visited. You order a non-veg meal, I ordered a veg meal. For me, French fries 1, Coke I got. For you also, you got your own respective French fries and you got your own Coke. For a veg meal, if I need a additional, I will get a Coke 2 for veg meal. If you don't need, then you don't get that one. If you need again, if you want to take another 2 Cokes, for your non-veg meal, you will get a 3 Cokes. For my veg meal, I will get a 1 Coke. Additionally, if you want to get, I will get. So now if you see, veg meal with a Coke 1, Coke 2. Non-veg meal with a Coke 2, Coke 1, Coke 2, Coke 3. Billing will happen like that only, right? Everything starts from the one only. Your Cokes is dedicated for your meal. My Cokes are dedicated for my meal. Similarly, here also, this meal is an image. To complete my meal, I need a Coke. Coke 1, Coke 2, Coke 3. That is for dedicated for me. Similarly, for you, that is your Coke 1, Coke 2, Coke 3. You cannot able to count, right? So 1, 2, 3 is, and 4, 5, 6 is the non-veg meal. You cannot able to count. So then you need to pay the bill for all these 6 Cokes.
Okay, fine. I have a question. Now here in this case, container 1, physical container 1.
Yeah.
Will that be having both service 1 and service 2?
No. Only which that container belong to which image? If it is belong to, it is consisting only that image only. That service one
for
only.
naming purpose, you are referring it as container 1, but they are different container actually.
Different container, yes.
For naming purpose, you are referring container 1 for both service 1 and service 2.
Yes.
But they're actually they are different. Let's say I can
Different
say
containers.
service 1 container 1. This is service 2 container 1. This is they are different.
Yes, exactly.
Okay. Got it.
Finally, single image you can run multiple containers.
Multiple images, yeah.
No, single image running multiple containers that is okay. Assume that just I am having one container. For that, I am trying to understand that one container will have both service 1 and service 2 or not.
No.
But every service will have its
Every service will have their
container.
independent containers.
Every image will have an independent container, understood. In the image, service is there. So that's how each service will have different containers. Okay, got it.
Yep. Yeah. So this is all about Docker and Dockerizing the Spring Boot application. So you can Dockerize through Spring Compose.yml. If you are having a single image, you can just use the Docker file. You can use that commands. Through that commands also you can do. So suppose if you configure everything in a Docker Compose.yml, so just a single command, you can just run Docker Compose up. Suppose if you go there and you open, you can just come Docker Compose down. Now it is going to be down all the services. So Docker Compose Cannot find a suitable configuration file. Oh, we are here. Let us go to that location. Composer file. Sorry. And Docker compose down. Now it is going to be shut down all the services. Okay,
Sir,
see, it is
how to
removing
push
the
that
network.
image into that public? Sir?
Docker push image name. Like
Here
git
only
push.
in the command prompt?
Yeah, through command prompt only. Wherever your Docker file is there, you need to open the command prompt, Docker push. Docker push the DTR you need to configure. So that DTR you need to first at the time of installation, you need to go to the configuration. There you need to make your resources. There you need to configure your everything. So then it is going to be mentioned. So
They're
there you need to,
providing any email ID or password details, those details?
you need to sign in there. You need to sign in. Like how you are going to set up in your Git. Similarly, you need to create your company username and password. So once it is authenticated, then it is going to be sync up with your company DTR. So like a Bitbucket URL, how you are having a Docker trusted URL you are having. So Docker push that URL you need to give. So then that is going to be put that push that Docker DTR. That's a
So,
long story. Yeah.
so how to create multiple container for a single image?
So one thing is automatically at the time of us starting up, it is going to be assigned some number of containers once it is started. Suppose if you want to configure, so at the time of us starting up application, you can.
So in this example, we have created one image and that one image contains one container only, no?
Yes.
Okay, and if I want to multiply it, how can I do? I want to create another instances of the same money image. I want to create another instances of the container.
Okay, so there you can just mention that Docker will do one thing. Docker PS. So there is, I didn't remember that a limit we are having Docker.
Sir, I have a question.
Yep.
So suppose that I have a multiple microservices, like example, one microservice I'm running the port 8082, another one 8083, 8084. So all the port I can expose on same port like 8080, 8080, 8080.
No, how can I start it? So each and every microservice is going to be run their independent port number. There,
Yes.
what you need to do is there you need something called as API gateway. If you take a API gateway, all the services is going to be exposure through your stuff. Single port number. Then you need to give something called as one this one router mapping you need to do.
Okay. Means it means like you have already used 8080 port, so which is already used. So suppose I have assigned my another service at 8082 colon 8080. So it will work same port or not?
No, it will terminate it there. Port is already in use, it will terminate.
Okay.
Then you need to
Okay.
change.
Okay. It means for different microservices we have to apply different port, right?
Yes.
Okay. Thanks.
Sir, suppose we have multiple application, suppose one for Java and one for .NET or Python, so running in one server only. So can we have only one container having all the application, having all the services?
Don't match the container with application here. Container is belonging to only for the sake of image. Every application is independent image.
Okay. And image is created with that Docker file only, sir, and
Docker file
container
only.
with the Docker compose, right?
Docker Compose also you can get the image. That's why you're going to mention this Docker file. Docker Compose, what will do is it will read this Docker file. So whatever the thing you mentioned in that, it is going to be update, create the Docker images.
Okay, okay.
Hi, sir. Sorry to disturb. The thing is actually sometimes they are saying it may happen actually. They are saying like image got corrupted. So please wait. We are pulling the image and re-imaging it. They are saying sometimes like that. So in that time actually, so all one image having multiple containers, right, inside it. So
Yes.
all containers got corrupted. Or
Yes,
what will happen?
that's what. So once your image is corrupted, then you don't have a choice. Then you need to wait. To manage that one, we are having the Kubernetes. What Kubernetes will is Kubernetes have a capability to maintain multiple images of the same application.
Okay.
So if you are having the Kubernetes, so then if one image is corrupted, so you can shift to the pod, you can get the latest image.
Yeah, fine, sir. So in this case, for example, we have a 3 environments. For example, dev, QA, or prod and prod. The thing is actually in dev, for example, in the image, they are created one image. So inside, for example, the people have a 3 containers. Okay, each container have a one image, sorry, one application running, right? So how this one, sir, in this happen? For example, actually in the Azure or whatever it may be, it will be auto scaling, right? So it will be increase and decreasing the servers, right? So it will happen in one image in the containers will increase and decrease, or images will increase and decrease.
Images will increase and decrease.
So in that case, one image having one container only in that case.
No, one image, that's all about your configuration. One image can consisting of a multiple containers. At the time of us starting how you configure, so that is going to be start those many containers. There is a virtual one.
Okay.
So that is actually here we need to configure the container setup. Once let us do one thing. Let me do Docker Compose up.
So in that case, for dev environment, we can create one image and we can create multiple containers, right?
That is actual process.
Okay. So, but in this case, for example, if that image get corrupted, then whole thing will get corrupted, right? The total environment get corrupted.
The total environment will not get corrupted. So that but a service will get corrupted.
How, sir? Because image having multiple container, right? If image get corrupted means our total all containers get corrupted, right? I'm getting confused, sir. So just wanted to.
So image is the dedicated for that service. Let us say payment service.
Okay.
Payment image.
Okay.
Order service. Order image. So if image get corrupted, environment means here you need to concentrate all the services combinedly you are calling as an environment. If my payment is corrupted, that payment functionality I'm not going to be working, but order image is going to be working as usual. Some kind of a invoice image, invoice service is going to be run on an invoice image. So only that payment image corrupted means that payment service I cannot able to run. That is, you need to redeploy, rerun.
Okay. So for example, what I'm understanding is, so for example, payment service is running one image, so it may have a multiple containers. So in that case, that is what you are trying to say, right, sir?
Right. Yes.
Okay. Thank you, sir.
So here, once you start your container, it has to give the volumes.
So before creating this one, we need to clusters. After cluster only, we need to create images, sir, or
clusters will actually undercome in a API gateway configuration, not here.
Okay.
So once you are having the entire images is there, and you need to serve the entire application and unified channel with a single domain. You need to serve all the application.
Correct, sir.
Then cluster you are going to be take that cluster you will configure with the API gateway. So there AWS Route 34 that's will going to be come to here.
Okay. Thank you, sir.
So here what will happen is, for example, if image is down, your service is going to be not working there. There you will introduce the Kubernetes pod we are having. A pod can consist of the multiple images of the same thing. So one image is corrupted. Let us say order service. 2 order images we are going to be running. If one order image is going to be corrupted, second pod is going to be activated. That order image 2 is going to be running. But individual Docker, we don't have that comfort. So that's where you are having the Docker Swarm we are having.
Okay, thank you.
Not giving this one.
Sir?
Yes.
Sir, I have just asked you regarding multiple microservices, which is a different port. Sir, as you as right now you have told, so for different port I have to use routing. So
right.
So sir, routing it is used for, we have already using the AWS routing. So the routing will be configured in Dockers or on AWS, sir?
That's configured in AWS only. Route 32.
So
Not in a Docker.
no need to be routing configuration in Docker.
Internal microservice communication. So service to service communication if you make. See, this routing will going to be involved for a external microservice communication. Internal microservice communication, there you needed this network configuration, Docker network configuration like this. For example, you are having the service one. Order service you are having. And you are having the payment service. And you are having the invoice service. So once you place an order, payment service, service to service communication, and you are having the payment service to invoice service. So for this internal communication, this Docker network is going to be help you. Docker network. But external, so let us say some UI app you are having. Those are not belong to my environment. That may be mobile or that may be desktop. So they want to communicate. So now suppose if you see your auto service is running on 8080, payment service is running on 8081. Your invoice service is going to be running on 8082. Let us say from this UI app, you want to check all your orders. So you will not communicate directly on 8080. Suppose you want to check all the payments you did. So that's not the good way you are going to be opening that from UI, you will going to be communicate entire 8081, not like that. So instead of this, what you will do is, suppose if external microservice want to communicate, you will keep some kind of a API gateway. API gateway will come here. Your UI app is going to be hit this API gateway. So this API gateway will have a single port number. Let us say it is having a 80 port number. Whatever the request coming external, you will hit this API gateway. This API gateway internally communicate with that payment service or route service or anything. So this is going to be giving the response. So internal service communication, this Docker network. So once the external microservice communication was happen, there your API gateway is going to be involved. So this is where your AWS Route 50 or something, you are having something called as a Spring Cloud Gateway or PCF Cloud Gateways will going to be come here. External microservice communication. That's what the infrastructure is going to be created. The entire infrastructure is a flow. We'll have a discussion on in a detailed discussion. There you need to discuss. So this
Yes,
is
sir,
all
got
about
it.
Docker. Yeah. So for that multiple container, so basically my Docker is not responding there. So it has to be, that's what I'm putting. Docker PS, it has to give.
Sir, sorry to disturb you.
Yeah.
Sir, like you are showing the Docker compose file, in that you had given a single image.
Right.
Yes, sir. So multiple means how to do it, sir? Around 10 to image I need to launch in a single compose file.
I will do one thing, dear, to put a full stop off for this one. So let us develop a new service. We'll start, we'll convert that is also image. We'll run 2 services at a time.
Okay, sir. Okay.
So let me quickly develop a new service, new Spring Starter project. This is a Spring Service Docker Demo 2. So Spring Docker Demo 2. Yeah, same thing. Next, just I need a web, Spring Web. That's it. Not more than that. Finish. Okay, so Spring Docker demo 2. No resources, static. Let me create index.html. Index.html. So this is Spring Boot service to, let me change something like teal color. So this I'm going to make a properties. So this also I will take a same app.jar I will take. I don't want to give this entire thing. Final name app I will just take. That's it. Okay. For this Spring Docker demo also, I need a Docker file. So I will simply copy the same Docker file. I will keep in our Spring 2 demo. This is the Docker file. Same thing, but port I'm changing. 7070 I'm keeping. That's it. Okay. Same command. Java -jar app.jar. Now this image will consisting service 2 image. So let me build my service 2 image. So cd Spring Docker demo MVN install I will do. This is the image 2 I'm creating for demo 2. Second service. Okay. So here, can I say same name app.jar for service 2 also? Can I continue?
Yes.
Yeah, sure.
Yes, you can, because this is service 2 image. Service 2 image, it's having its own infrastructure. It is available in its own app.jar. The same thing I'm going to be giving. So now this I need to build. So here docker compose.yml we are having here. I will do one thing. I will keep this docker compose.yml outside. If I keep outside, again it will going to be okay. That's fine. From here I will refer that one. No issue. So we are available here. We need to come a step back. Then I need to make a Docker file. So currently compose.yml is Docker demo. Step back. Then we need to go to the demo 2. Here we need to refer this service Docker file. Coming to the compose.yml, Docker compose.yml. So similarly, I'm having the service 2. Your choice here. Name whatever you want to keep, you can keep. Service 2. Image, you can keep a Spring Docker demo 2 I'm keeping. So just I'm keeping my name as a Spring Docker demo 2. So one thing. Sorry.
So can we have same name for 2 images?
You can keep, but at the time of starting, how you can identify which image is this one?
Service
Docker
ID.
don't have any confusion. It will use ID. But for you, how you can identify? Tomorrow you want to debug which country is up running, which country is down.
Okay. It's possible, but ideally we don't take them like that, right?
Yes. Because basically Docker will use its image IDs, container ID, image ID it will use. It don't have any issue. But for us, if I use the same image name, Spring Docker demo, tomorrow I need to debug, little bit difficult. So same thing. So just I will do one thing. 8070 I will keep. Similarly, 8070 I will keep. And the same port number. We need to do that one, right? Because in our application.property Spring Docker to demo, server.port 8070. I will keep. Like a system, how you can define environment variables, you can define environment variables for Docker also. Yeah, server.port, it is build was done, and now we are having the docker compose.yml. But in a docker compose.yml, we need to change a slight thing there. So this we are building for demo 2 image. I'm going to be building this. I'm going to be building for this Docker file available in other location. This is for dot slash. I need to come a little bit back now. It step back. This I will keep here. That's it, Docker file. So now this image, it is going to be read the Docker file for your Spring Docker demo. So there I'm going to be running my application. That's it. So now go to your wherever your Docker compose is there, cd Spring Docker. So let us say compose.yml is here. Yeah. So Docker compose. First, let me down. It is actually removing for a refresh. Yep. So Docker PS, nothing but present services, running services, nothing is going to be running. We can check here also, images, nothing is going to be running, then there's nothing is going to be running. Simply what I will do is Docker compose up. Now first Spring Docker demo with a default driver. So now building service 2. Service is nothing but what you configured here. So service 2, this one. So that's automatically building image, downloading the image, everything. Service 2 was built because it did not already exist. Okay. So rebuild this image must be Docker compose. Okay, that's fine. This is just a warning. Is actually building a service studio. Meanwhile, you can check here. So images, Spring Docker demo is created. Docker 2, what we created, that is also created. Okay, so now my 2 application is going to be running, service 1 and service 2. Service 1, service 2 application is running. So one is run on 8080. Second should be run on 8070. Okay, so it's both up and running. So now I can just check. So 8080 application is running, and the second one is 8070. It's still not up. Let us wait. Let us go to the Docker in news containers. Only one is running. Basically, if you see it, Docker demo, it run as a 2 containers. Let us come back. We are having the services. Service 1 we are having. Service 2 we are having. Docker demo context Docker file. Okay, 8070.
Sir, in Docker file, you have given 7070 expose port numbers.
Is it? Oh, good catch. I will do one thing. Here I will change directly in a Docker compose.yml. I will change 7070.
Sir, sorry to disturb a small question, sir.
Yeah.
Sir, Docker basically Docker daemon will run default in Linux operating systems, no, sir. Here you are explaining Docker desktop, which is completely confined to Windows, right? Sir?
On top of that, on top of a Docker daemon, this is a layer. Docker desktop is a layer.
Which visually we will be seeing in this Windows environment, right? Sir?
Windows environment, yes. For Linux, don't expect that. We don't have that.
Yes, sir. Basically, we have been practicing in Linux environment, but our desktop is usually in
There you are
Windows.
having the portainer we are having there for Linux. Portainer we are having. This will actually show all the images, everything, how you will build. If you are using a Linux, you can use this portainer.
Okay, sir.
Docker portainer.
It's completely Linux OS environment based.
Linux version and yeah.
Thank you, sir. Thank you.
It is up. Now let us up. So powerful container management for your platform teams. It will come like this. So it will show all the images, everything. What are the images you are having? This is for Linux. Okay, it's still up and running. So 7070. There is something messed up. Let us go and check images. 7070. That is local host. There is some issue what happened here. Created. What is the issue? Okay. Try to started. It is actually pointing 8080. I think maybe in our application.properties we give an 807. Oh, here we give an 8070 already, but earlier 7070. Docker, everything is messed up. So application running on 8070, Docker file will export the 7070. Let us make this one as 7070 only. Let us just do a quick round of investigation. I will take a server dot port. I will take this as 7070. Great. And our Docker file expose 7070. Great. And coming to the Docker compose. Okay. So let me do one thing. Docker compose down. I think actually we planned this is for only for 1 hour, but it led it to almost 2.5 hours. 9 o'clock we started, 9 to 10, 10 to 11, 2.5 hours. A lot of people already lost the patience, I think. But at least they got a concept.
No, sir, we're getting very good subjects.
It's good, sir. We are seeing the troubleshooting also, no, sir? Mainly.
Yeah.
Okay, so I will do one thing for our safe side. I will remove images. You can just check Docker images. I want to rebuild images, but meanwhile, first I need to build my application because we changed the port number. Vn install. As a quick check, let me do one thing. Java-jar app.jar. Started application on 7070. Great, that's fine. This is what we are expecting. Okay, so application build was done, and let us put it back. Coming to here, so Docker images. Docker RMI safe side. I'm removing the images. You can give the entire image ID or image name, or you can just give a for a first 3 words also fine. Docker chemist. Okay, remote similarly Docker demo 2. Common unable to remove repository must be forced. Okay. It is removed. Docker images. One image is there. So see, if you didn't give any kind of a name, it is giving image ID. Docker RMI. Conflict unable to delete being used the container. So let us make RM and take a Docker PS. This is the container running. So because image is run in a multiple container. So first let me remove the container. Docker RM for the container remove. So you can just give that container ID. First 3 words, 4 words is sufficient. Response and stop container before. So for that, Docker kill that container. We need to kill the container. Yeah. So now removing the container. Remove. Now Docker RMI image for CD removed. So image is deleted. Docker images. Now we don't have any images. Fresh one. So now Docker compose up.
Sir, in the Docker compose, hyphen is must now, sir. That is the default.
Docker?
In the Docker compose, in between you mentioned hyphen, or for up and down, you have to mention that hyphen is must.
Docker hyphen compose hyphen up, you are asking, or?
No, sir. Docker compose in between only, you should keep hyphen, right, sir?
Right, yes.
For up and down, you have both, you have to mention, right?
Up and
Docker compose, Docker
up.
hyphen compose up should be there, and Docker hyphen compose down should be there. Both you have to keep hyphen.
That is a syntax here.
Yeah,
Syntax,
okay. Okay. Thank you.
So image 1 is there, image 2 is there. So meanwhile, you can just come here, Docker desktop images, 2 images created, but still containers, it's unable to run. There is something you are missing. 8080 is running, and coming to this one. And 8080, I think it is expecting a network configuration. So service 2 is not running. Somewhere it is missing. Network configuration. Okay, well, let me do one thing. I think it is expecting some kind of a network configuration. So I will create that specific network channels. Networks. One dedicated network for this one. So Spring Boot might say one I will create, and for this network I will expose. Sometimes what will happen is it is unable to pick up automatic port number, so I will configure. So the same network configuration I will keep for this port also. This is 7070. Save it. I will do one thing.
Sir, you mentioned the Spring Boot 1, both sides.
Is it?
Spring Boot 1.
Oh, thank you.
Spring Boot 2.
Docker compose down. Okay. Selenium. Host now 7072. Is running here, and this is also running on a 0 bit weird. Okay, so let me stop this as well as stop this. Now to do this. And that's the reason I generally use the Command prompt. Just a minute. So which is already image is running with the one container ID. You can just to copy this container. First 4 letters is sufficient, or 3 letters, Docker rm. Okay, it is removed. So now removing this one. Yeah, it's removed. So similarly, I'm removing this 4CD6. So this is the container ID. Okay. It's removed, and let me just we have this one and the Docker demo. We'll take the context in this one. Okay. I think context is not required. We'll remove that context. Okay, so we have image we are having ports also 8080. Networks we given, expose we given. That's fine. And servers too. This is image too. Okay. Build a context. I'll just keep a dot here. And the Docker file. Coming to Spring Boot 2 Docker file, I'm going to be running. So from here, stepping a bit back. So currently we are here. Current working directory, stepping a bit back. Current directory, stepping a bit back. Spring Docker demo 2. Spring Docker demo 2. Here we are having the Docker file. So this Docker file had all those things. Just a build that. Exposing 7070 OpenJDK 11 app.jar. Okay, that's good. That's Docker file we are going to be configuring. And ports 7070. I think I will remove this colon. Spring Boot 2, that's I will take, and same thing, exposing all those things. Fine. Expose 7070. I think basically I don't require this thing. While defining, I don't require this. I can just mention ports 8080. Similarly, ports 7070. Okay, so first let me check is AML is a valid or not, because indentation is a mandatory. YAML validator on that. Just give me a minute, getting a call. It's just I'm trying to validate. If anything goes wrong, it will just suggest us online validator. It's better to sometimes validation is required. So because what it will is, if you give any kind of a wrong step, simply Docker will neglect that one. It will not give any kind of errors for us. So save it. So 7070 expose. Oh, we didn't copy this expose. expose 70708080. Great. So now let us build this one. Docker compose up. Docker compose service one uses an undefined network. Spring Boot one undefined network is using some undefined network. Service one networks you are having. Undefined network Spring Boot network Spring Boot 2. Maybe in a version 2 we'll get this one. Okay, my bad. So we need to define the networks. I forgot to define the networks. That's we need to define here. Networks. This is my network. Spring Boot 1 is the one network. It's like a variable. First you need to declare, then you need to use. And similarly, Spring Boot 2 network. So whatever the proxies if you want to configure, you can just configure for this Spring Boot 1, Spring Boot 2. That's error it is actually telling. So you can see it is creating the network for a Spring Boot 1, Spring Boot 2. Building service 1, building service 2. Service 1 of 1. So which means service 1 of 1. So which is service 1 is the image. This hyphen 1 is the container. Service 2 for service 2 container 1. I suspect, wait a minute. I suspect one thing is by chance, is Kubernetes overriding my stuff? Okay, let us wait. This is not the good time to. Okay. Okay, so it's been 12 o'clock. It's also a little bit late. So 8080 working fine, but a second service it's not running. So I will commit this code here in GitHub. So we'll validate some other time. So that's not an issue. Just wait a minute. As I mentioned, maybe Kubernetes is a. Oh. So my Kubernetes is actually not propagating the URL. That's fine. Okay. So basically, there is some Kubernetes configuration overriding my configuration. All the services it is taking the single port. So that's I will configure and I will share that through a GitHub URL. So, but the configurations looks like this one already. Yeah? If you are having the multiple services, you are going to be keeping all these things. So generally, we'll upload the Git URLs here. So GitHub URL from that batch 8 o'clock batch from there. So you will get this prime trainings. So all the code I'm going to be uploading here. So you can just check out this URL. I will ping in a chat. Okay. I will modify that code. I will upload that one. So this is Docker, everything I'm going to be uploading here. So you can just have a look on this. So then you will get an overall exposure, how you can run the multiple microservices. Meanwhile, I will fix that one. I will upload that one. Okay, because it's already late. I don't want to make you guys wait. So that's what. And thank you for those 37 people who are waiting. So this is all about the Docker. And thank you so much for your patience. Have a good day. Bye-bye.
Thank you so much, sir.
Yeah, if you have any questions, try to reach out to the admin team so they will redirect to me. No issue on that.
Thank
Yeah,
you, sir.
sure.
Thank you. Thank you so much, sir.
Thank you, sir.
Thanks, Yash. It was a wonderful session.
Really wonderful session, sir. Thanks so much.
Thank you.
Kubernetes, any idea, sir?
Kubernetes also have a plan to conduct because we are in a plan to launch this DevOps full stack course, like a Docker Kubernetes. So before launching, we will conduct the workshop same like this, how to run an application on a Kubernetes.
Your batch, sir?
Yeah, so basically I'm dealing with the Spring Boot microservices on the extension of this doc in a plan to launch the Docker, either Docker or Angular. I mean, the DevOps or Angular are going to be launched.
Sir, are you taking any current Spring Boot batch?
It's just over there last Friday, maybe next Thursday onwards, morning 8 o'clock or evening 7:30.
You're planning to start now?
Yeah.
Okay, so are you going to take Docker as part of that, or that will be an additional boot?
Docker, these things I will explain there. So like how you are going to be running the Spring Boot Docker, not the entire thing. If you need the core concept, the entire Docker, that is covered in a DevOps course, not in a Spring Boot course. So in a Spring Boot, we are discussing the Spring Boot microservices, Spring Cloud, Spring Data, so Spring Security, like OAuth to authentication, basic authentication. So that's what we are discussing.
So we can expect that batch by coming Thursday.
Thursday or mostly on Thursday. If it is missed, then next Monday.
Sir, for Spring Boot, how much Java knowledge is needed, sir?
Believe me, if you know, just because in my Spring Boot course is designed, initial things I'm going to be taking care. If you are good enough with the core Java, basic of a JDBC servlet, that is sufficient.
Okay. Suppose I'm totally new to Java, means can I manage this one, sir? Spring Boot, or should I cover Java first?
I don't recommend here. It's not the sake of the business. Okay. I don't recommend generally. So first complete the Java, no need to be hurry. Take the intensity of the subject, then you will get a little bit exposure on that. I don't recommend, but at least if you complete the core Java, then you will get how we can work with the Spring, all those things.
Okay. And how about the job opening for Spring Boot, sir? Nowadays, comparative to DevOps?
Comparative to DevOps, it's I cannot able to. There is no comparison.
Okay.
Both like sort of their area. Because if you ask me Java.NET, both are fighting together, then I can tell. But both are hand in hand. Both are friends. That two best friends. No one can blame each other.
Okay. So there is more openings in Spring Boot also.
Obviously.
Okay.
Yeah. Thank you. Have a good day.
Thank you, sir. Thank you.
Thank you, sir. Thank you for the session.
For Angular means what you teach, sir? Full stack, huh?